So today we're going to talk about absolute value inequalities. And the interesting thing about absolute value inequalities is once you start to work them, you realize that they're just the exact same as compound inequalities. So what we learned in our last class and what we're learning today are very closely related. So let's see how we can show that by solving these two examples next to case 1 and case 2. So I have the absolute value of x is greater than or equal to 5. But before we get started on that, let's think about what we would need to do if all it said was absolute value of x equals 5. So if it said absolute value of x equals 5, then I have an absolute value equation. I need to make two cases. This is x equals 5, and remember the only thing I changed when I make my second case is I changed the answer side to a negative 5. So we're going to do something similar here. We have x is greater than or equal to 5, so notice that I haven't changed anything. I've kept everything the same. All I've done is dropped the absolute value bars. That's case 1. Case 2, I need a 5 that has a negative on it and the x, just like I did over here for where I solved the equation. Only for the inequality, when you make your second case, you also have to make sure that you switch the direction of your inequality symbol. So instead of what we started out with, our second case is x is less than or equal to negative 5. So let's graph this and see what it looks like. We have x greater than or equal to 5. That means I need to come over here to the graph. I need a closed circle over 5. And then the arrow is pointing to the right, so I need to go to the right. You want all the numbers bigger than or equal to 5. So I've drawn the arrow going in the direction where all the numbers are bigger or equal to 5. Next, we want to graph the other part, x less than or equal to negative 5. So I need a closed circle over negative 5. And then all the numbers less than negative 5 go to the left. Okay, so remember from previous classes that less than or equal to, greater than or equal to get closed circles. So that's why I've used closed circles in this example. Less than, greater than, without the equal to underneath, get open circles. Okay, so what we're noticing here is this graph looks just like the compound inequalities from last class that we called the OR compound inequality. And the reason why we know it's an OR is because the two pieces of our graph go apart from one another. So we know this is an OR because the two parts of the graph are going out from one another. So what can we say? We can say, we're not going to worry about interval notation. We're actually going to put inequality notation here. So what does inequality notation say? If we're doing this, we need to go from left to right. So we need to start with the smallest number first. Our negative 5 is the smallest number, so we're going to go x less than or equal to negative 5. Then we're going to put OR in the middle, and x is greater than or equal to 5. So in one of the IXL assignments that you'll do today, this will be your answer. You'll have to decide after you've graphed whether it's an or an and you'll need to put the word that goes with the graph in the middle of your two inequalities. So let's start over with number 2 here. I'm going to make my 2 cases. This is x less than or equal to 8. And when I go to make my second case, x stays the same. I switch the direction of the inequality, and 8 turns to -8. So right here, x less than or equal to 8. I need to draw a closed circle over 8, and then I want the numbers less than or equal to 8, so I need to go this direction. Then for the other inequality, we want x to be greater than or equal to -8. So I'm going to need a closed circle right here over -8. And I'm going to draw my arrow going to the numbers that are bigger than -8. Okay, you notice from this graph that this is an and. Okay, so a or goes apart. Talked about this yesterday. And goes together. So my arrows are coming in, going together. So this is an and inequality. Again, I'm going to start with the one that's the smallest. X is greater than or equal to -8. And x is less than or equal to 8. And again, this is an interval notation. This is inequality notation. But this is the answer that you'll put in the IXL that you do later. So what does this mean? This means that absolute value inequalities are really just compound inequalities, what we said from the beginning. Anytime that you have greater than or equal to, it's more than likely going to be an or. So here we started out with greater than, and we had an or compound inequality. When we start out with less than or equal to, most of the time this is going to be an and. So here we started out with less than or equal to, and here we had an and compound inequality.